Alright guys, welcome to our Unit 2 FRQ Test Study Guide. I'm going to go ahead and be going through the even problems, and then I'll let you guys do the odd ones. Except at the end, I'll probably just do all of them. But for the time being, number 1 I'll skip because it's a lot like number 2, but I'll go ahead and do number 2 here. So let's begin here. It says the height of a golf ball is given by the function h, where h is measured in meters and t is measured in seconds. And then selected values of h are given in this table. We want to find and interpret this value here. Alright, so the first thing I'll be looking for is the actual integration of h prime, which is h. And then we put brackets instead of an integral. And then we go ahead and we put the limits out here. The next thing I'll be looking for is the fundamental theorem of calculus, where we do plugging in the limits. The last thing I'll be looking for is the answer. H of 7 is 4.1, and h of 0.5 is 17.2. And this is an FRQ, and I don't really feel like subtracting those, so I don't have to. I can just leave my answer like that. And we want to now interpret our outcome there. So let's go ahead and do that. So before I do that, let's make sure we understand what these numbers are. H of 7 and h of 0.5 are these numbers down here. And those are meters. And so basically what that means is that from the time 0.5 seconds up to the time 7 seconds, the height of the golf ball has changed from 17.2 meters to 4.1 meters. Okay, so it's decreased by this much, in other words. All right, so that's going to be our interpretation. So let's go ahead and write that out. Oops, just a moment. I'll start retyping here. The height of the golf ball has decreased by 4.1 minus 17.2 meters on the interval t equals 0.5 seconds to 7 seconds. Now, how do I know it's decreasing? Well, it's obvious. Like we're going from a bigger height to a smaller height. But also, if you were to do your subtraction here, which I was being too lazy to do, which you don't have to do if you don't want to, is that's going to be a negative number. So the fact that it's a negative amount is my hint that it's decreasing. Now, if it were positive, we would say that it's increasing. All right. So that's the kind of stuff you're going to need to do. You're going to get 1 point for doing the integration process and getting the answer, another point for identifying the units correctly, and then another point for writing out your interpretation correctly. Let's go ahead and move on to number 4. All right, so for number 4, we have this table here, and we're given some functions f, f prime, g, and g prime with specific values given for each. Now, I wanted this integral here, and I noticed that we have an inside function, and I see the derivative of that inside function right here. And when you see that, that's one of your indications that you're going to be doing u substitution, where we make u equal to the inside function. All right, so let's go ahead and continue on with the process there. So the first thing we do is take that derivative. The derivative of g prime is g double prime. And then if I get dx by itself, get that. So now, let's go ahead and write this out. We have f prime. And instead of the g prime, I'm going to put u there now. I'm going to keep the g double prime out there for now, and then I'm going to replace the dx with du over g double prime. And these guys are going to cancel out, right? We also need to change our limits. The limits are -1 and 2. So let's start off with a 2. How can I change that? Well, we come back to our u expression. U is equal to g prime of x. So I'm going to plug this in for x and see what we get for u. Using our table, g prime of 2 is 5. So that means u equals 5, and therefore that'll be my new upper limit, which I'll put up here. Do the same thing for the lower limit. We're going to plug in -1, and using the table, g prime of -1 is -4, and that'll be my new lower limit. So just to go ahead and rewrite all this stuff so it's a little bit prettier, we now have the integral from -4 to 5 of f prime of u du. So next we go ahead and do our integration. The integral of f prime is f of u. And then put our limits out there. We do f of 5, our fundamental theorem of calculus. Oops, it's not 5, it's 4. All right, so f of 5 is 15. And f of -4 is -6. Double negatives go positive. Final answer is 21. All right. So a little u sub there. We got another u sub question coming up here on number 6. So once again, as you guys can see, I've got an inside function. And if you take the derivative, you get 2x, which will cancel the x out here because the derivative's out there, right? So we can go ahead and do u sub again. My u in this case is going to be x squared plus 1. The derivative with respect to x is 2x. And getting that dx by itself will give me this. So you know what, I need to change this to a g prime really quick. There we go. All right, there should have been a g prime here. I had a typo, I had to fix it. All right, moving on. So doing our u substitution, we have g prime, the x squared plus 1 gets replaced with u. The 4x is going to stay there for now. And the dx gets replaced with du over 2x. And in this case, the x's are going to cancel out, which is what we want to have happen. And then 2 goes into 4 twice. And then that 2 is... Now, this is something that I've noticed a lot of my students are struggling with right now. When they bring this number out, they're not sure if it goes in the numerator or denominator. Well, you just have to ask yourself, where is it right now? It's in a numerator, so it's a normal 2. Now, if you had a 2 left over in the bottom, when you bring it out, it's a 1 over 2. But in this case, it's in the top, so it's 2. And I'll cross it off since I put it out there in front. So we need to go through and change our limits. So my upper limit is 2. So once again, I'm going to take my u expression, and I'm going to replace the x with the number on top. And I get 5. So that'll be the upper limit there. And then I'm going to go ahead and change the bottom limit, -1. And that becomes 2. So if I were to write this a little bit more clean now, we have a 2 in the front, 2 on the bottom, 5 here. G prime of u du. Next thing we're going to do is we're going to integrate g prime, and when you integrate g prime, you get regular g. Then we're going to do our fundamental theorem of calculus. Okay. Need a little more writing space here. All right, so first we have g of 5. So g of 5 is negative 8. So 2, and then g of 5 is negative 8 minus g of 2 is negative 1. Double negatives go positive. That's negative 7 now. Final answer, negative 14. And there you have that. All right, so you'll have some problems like that as well. Let's go ahead and move on to the last set. On the last set, I'm just going to go ahead and do all of them. I'm not going to do just the even ones, I'm pretty sure. So let's go ahead and get started here. All right, let's go ahead and sketch our slope field for this differential equation at the 8 points indicated. There's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so just start with a point, right? Pick a point. I'm going to use this one. That point has coordinates negative 1, 1. So I'm going to plug in negative 1 for x and positive 1 for y into this little formula up here. And I get negative 2. All right. So now the most important thing is to recognize that the slope moves in a downward direction. So I need to have that. The second most important thing, although it's really not as big of a deal, is the steepness of the line. So a 45-degree angle is like a perfect diagonal, like it goes from here straight to the origin, makes a 45-degree angle. Half of 90, in other words. That's a negative 1, but this is actually a negative 2. So we want it to be a little steeper than that, so I'll make it look like that. A little bit more than 45-degree angles. All right, so let's do another one, and then I'll let you guys do the rest. Now you'll notice here on this side, they're both positive 1, so that gives me 1 plus 1 over 1, and I get the same answer, only it's a positive 2. So it's going to be just as steep, but it's going in the opposite direction. So it's going to look like that. And basically at that point, we're just going to go through and do that for all these points. So I would encourage you, to, if you haven't already done so, to pause the video and do the rest on your own and check your answer with mine. I'm going to go ahead and do it. So go ahead and pause the video here, and when you unpause it, I'll have all the slopes up there. So it's kind of hard to get these things to be exactly right. Like these are supposed to be 2s, right? So they're supposed to be steeper than 1s. These are supposed to be 1s here, but you can barely tell. I really tried to get them to be a little bit less steep. So these are 1s. These over here are slopes of a half, negative on this side, positive on this side. So these should be slightly flatter than the 1s, and then also we should have 0s here. So the 0s should be there. So just so you guys know, when these things are being graded, here's what they really look at, though they don't really care too much about the steepness. All they really care about is the negatives. Did you have all of these as negative and all of these as positive and these as 0s? If so, then you would get full credit for that. That's kind of what they look for, just the directions of the lines. All right, let's go ahead and take a look at part B. And hopefully, you guys are trying these things before you're watching this video. The video, in this case, is really just it's not meant to serve as a reminder. I would say up here for these problems, you can use it as a reminder, like, oh, I forgot how to do this. Let me watch this, and then I'll try number 1. That's fine. But down here, I'm not giving you repeat questions, so you can't try it again. Also, we've done these so much that I'm hoping you guys already have an idea of how to do it. And I wouldn't just watch me do this at this point. I would make sure you guys are actually trying it first and then comparing your answer, because practice is running low at this point, right? So you want to make sure you're getting as much practice in as possible. All right, so let's begin. These These are worth a lot of points in the part B here, so make sure that you're aware of how the points are distributed. The first point is for separating the variables. So the first thing we're going to do is we're going to take the dx and move it to the other side. The next thing is that entire expression there in the numerator, we're going to move that to the other side. Now, when we do that, since it's in the numerator, we're going to divide it on both sides, which means that when we're done, it's going to end up in a denominator. And so here's what the final step will look like if we have separated our variables correctly. Okay. All right, the next thing we're going to do is we're going to integrate both sides. All right, so this is ln of x plus c. And then this side, now you could do a u substitution where u is y plus 1, but I also gave you guys, and I've talked about it a few times, a shortcut. And the shortcut is you have this number over the number in front of the y, which is a 1, ln absolute value of the denominator. Now that shortcut only works when you have a linear function on the bottom, like an ax plus b, or in this case an ay plus b. But those are actually pretty common, and so it's nice to have a shortcut for them to save us some time. But if you can't remember the shortcut, then just go for it and do the u sub. But notice I erased the 1 over 1 because 1 over 1 is just 1 and we don't really need to write that. So step 1 is to separate the variables. That's 1 point, so I got that. Step 2 is to integrate both sides. Each of those are worth 1 point, so now we're up to 3 points. 1 point for this side, 1 point for that side. Point number 4 is to find your c value. So I'm going to plug in the initial condition that they gave us. We're plugging in -1 for x and +1 for y. So if I do that, then I get the following. So this comes out to be ln of 2. Now the absolute value of -1 is 1, and ln of 1 is 0, so that just kind of goes away. And so I'm left with c equals ln of 2. It's kind of a weird c value, isn't it? But there it is. All right, so that's another point. So now we're up to 4 points on this question. Point 1 is separation. Point 2 is integration. And point 3 is finding, well, actually, point 3 is also integration. Point 4 is finding c. Now we're ready for our last step, which is the last point, which is getting the y by itself. Now, to get rid of an ln, what we're going to do is we're going to exponentiate both sides. And what that means is both sides of the equation become powers of e. Like that. So these cancel out. And now I have the absolute value of y plus 1 equals e to the ln of x plus ln of 2. And we can get rid of these absolute value bars if I put a plus and a minus there. So now I've got y plus 1 is equal to plus or minus e ln of x plus ln of 2. The last thing we're going to do is minus this 1 on both sides, so it looks like that. Okay, so now we have a positive e and a negative e, and we have to decide which one is the correct one. Now, let's go ahead and see which one it is. To do that, we're going to plug in our numbers. We're going to plug in -1 for the x and +1 for the y. So if I do that, I get 1 equals plus and minus e to the ln of -1 plus ln of 2 minus 1. All right, well, as we already said earlier, this equals 0. And 0 plus ln of 2 is just ln of 2. All right, next, these are going to cancel out. And now I have 1 equals plus and minus 2 minus 1. And now we want to see which one of these things will give us our answer here. Is 1 equal to 2 minus 1, or is 1 equal to negative 2 minus 1? Well, 1 is equal to 2 minus 1, and so that's the one where we take the positive 2 value. And so since the positive 2 is the one that works, our final answer then is going to be the positive e ln of x plus ln of 2 minus 1. Okay? Let's go ahead and move on to number 8. Number 8, sketch the solution curve through the point 0, 1. So the first thing we're going to do is put a dot at 0, 1, that's here. And then basically at that point, you want to imagine it's kind of like a leaf that's been tossed into a moving river, and these lines represent the current of the river. So if that dot's a leaf in that river following the current, it would look something like this. Well, it's kind of difficult to tell. Is it going to bit back up, or is it going to probably look something like that, I would say. Excuse me. All right, and there you have it. Once again, this is not going to be an exact thing. So long as you have the general shape right and the general size close to what it should be, then you'll be pretty good. Okay. Let's go ahead and take a look at part B. So write an equation of the line tangent to the solution curve in part A. That should say part A. Excuse me. At the point 0, 1. All right, so we want it. This is actually a unit 1 question, writing a tangent line. Now, what you need for a tangent line is you need an x value, you need a y value, and you need a slope. Okay. Well, here's our x value and y value. So that's nice and easy. The last thing we need is a slope. The slope is the derivative when you plug in the numbers that they give you. So we have 3 minus y, and my y value is 1. And then cosine of x, my x value is 0. 3 minus 1 is 2. Cosine of 0 is 1, and so I end up with 2. So there's my slope, and my tangent line then would be y equals my slope, x minus x1, plus my y value. And there it is. So that's a review question, but the reason I included it is because on the actual AP exam, it's not uncommon for them to throw a question like this on there. So let's go ahead and move on to part C. They want us to find a particular solution. So once again, we're going to multiply the dx over here. And then notice this 3 minus y is in the numerator. So I'm going to divide it to the other side, which means it's going to end up in the denominator. And as a result, we will have the following expression. And that's 1 point, separating those variables correctly. Next, we want to integrate. The integral of cosine is sine. Don't forget your plus c. And then the integral of this guy, well, once again, we've got another shortcut that we can use there, right? So the number on top over the number in front of y on the bottom, which in this case is a negative 1, so you got to be careful with that. And then ln of the absolute value of 3 minus y. All right, so we're up to 3 points now. 1 point for separation, 1 point for integration on each side for a total of 3 points. So now I've got negative ln of 3 minus y equals sine x plus c. Let's go ahead and find our C value. We're going to be plugging in 0 for x and 1 for y. So if I do that, I have the following. Oh, 0 goes here. Sine of 0 is 0, so that just goes away. And this one is negative ln of 2. So there's our C value. So C is negative ln of 2. We're going to go ahead and plug that into our equation up top there. And now we're up to our fourth point. Plugging in our C value, it looks like that. Last thing we want to do is get the y by itself. So the first thing I'm going to do is get rid of this negative in the front. You can't have anything outside the ln if you're going to exponentiate both sides. So I need to get rid of that negative. So that's going to change this to a negative and this to a positive. Multiply both sides by a negative, basically, right? And then we exponentiate both sides. So now we have, oops, it's not y, it's minus y. These cancel out, leaving us with absolute value of 3 minus y equals this. All right, these absolute value bars here go away if I put a plus and a minus. And then I'm also going to minus the 3 on both sides. And I still got a negative there in front of the y. So I'm going to multiply both sides by a negative 1. Now, that's not going to affect the front here because it's positive or negative anyway, so it doesn't matter. But this one, 3 over here, will become plus. All right, so that's where we're at the moment. And as we had in the last problem, once again, we have to decide, does it come out, is it the positive one or is it the negative one? And to answer that question, we're going to go ahead and plug in our initial condition again here. So I'm going to plug in 1 for y. And 0 for x. So sine of 0 is just 0. And 0 plus ln of 2 is just going to be ln of 2. So now it's e ln of 2. These cancel out, right? And so now I'm left with plus and minus 2 plus 3. And in this case, the what's going to work? Is it going to be 1 equals a positive 2 plus 3? Or is it going to be 1 equals a negative 2 plus 3? Well, this is false, right? And so it's going to be the one with the negative in it. And so our final answer will be y equals the negative e. Like so. All right. And that does it for our FRQ study guide. Hopefully that was helpful, and we'll wish you well on your test.